Saturn, the sixth planet from the Sun and the second largest in our solar system, the jewel of our solar system. Its beauty is unparalleled, with its iconic rings that have fascinated astronomers and stargazers for centuries. This gas giant is instantly recognizable even from millions of miles away. Its rings, composed of ice and rock, create a mesmerizing spectacle. Why? It boasts a stunning system of rings that span almost 200,000 miles, which is nearly the distance between the Earth and the Moon. These rings are divided into 7 groups, each with its own unique characteristics. But there's so much more to Saturn than meets the eye. Beneath its thick atmosphere lies a world of mystery and wonder. What lies beneath those magnificent rings? Saturn's atmosphere is a turbulent mix of hydrogen and helium, with powerful storms and winds that can reach speeds of over 1,000 miles per hour. Let's take a journey to uncover the secrets hidden deep within this enigmatic gas giant. From its core to its outermost rings, Saturn holds many surprises. Imagine yourself on a spacecraft, ready to plunge into Saturn's swirling clouds. As we descend, we'll encounter layers of clouds, each with its own unique composition and weather patterns. What awaits us on this grand adventure? The deeper we go, the more we learn about the planet's structure, its magnetic field, and the secrets it has guarded for billions of years. Join us as we explore the ringed wonder, Saturn. Our descent begins high above Saturn's atmosphere. From here, we can observe the planet's swirling clouds of hydrogen and helium. These are the very same gases that make up our own sun, but here, they exist in a much colder, less energetic state. As we begin to descend, the pressure increases. The faint smell of ammonia mixed with the tang of sulfur pervades the air. The temperature remains frigid, a consequence of Saturn's immense distance from the Sun. Our spacecraft plunges deeper into Saturn's atmosphere. The pressure continues to mount, growing hundreds of times greater than what we experience at sea level on Earth. The temperature rises as well, but the environment remains far from hospitable. We are now in the realm of supercritical fluids, where the distinction between gas and liquid becomes blurred. The hydrogen, once a wispy gas, now behaves more like a dense, swirling ocean. This bizarre, otherworldly environment stretches for thousands of miles. Section 4. The Heart of a Giant. As we approach the heart of Saturn, we encounter a mystery. Saturn, the sixth planet from the Sun, is a gas giant known for its stunning rings and immense size, but beneath its beautiful exterior lies a world of secrets waiting to be uncovered. Deep within the planet's core, scientists believe, lies a dense, rocky core. This core is shrouded in layers of hydrogen and helium, creating a complex and dynamic environment that challenges our understanding of planetary formation. This core, likely composed of heavy elements like iron and nickel, is thought to be many times the mass of our own planet. The presence of these elements suggests that Saturn's core could be a remnant of the early solar system, offering clues about the processes that shaped our cosmic neighborhood. But what state is this core in? The extreme pressures and temperatures at Saturn's center make it difficult to determine its exact nature. Scientists use advanced models and simulations to hypothesize about the conditions within this giant planet. Is it solid, crushed under unimaginable pressure? The immense gravitational forces could potentially compress the core into a solid state, creating a dense and compact structure. Or is it a swirling molten ball of liquid metal? Some theories suggest that the core could be partially molten, with heavy elements in a liquid state due to the intense heat generated by the planet's formation and ongoing gravitational compression. The exact nature of Saturn's core remains one of the greatest unsolved mysteries in our solar system. As astronomers and planetary scientists continue to study this enigmatic giant, each new discovery brings us one step closer to understanding the true heart of Saturn. Section 5. Unraveling Saturn's Secrets. Saturn holds many secrets, puzzles that continue to baffle scientists. For instance, the planet's magnetic field is surprisingly aligned with its axis of rotation, unlike Earth's tilted magnetic field. This alignment remains unexplained, challenging our current understanding of planetary magnetism. Furthermore, the exact age and origin of Saturn's rings are still debated. Some theories suggest the rings are relatively young, formed from shattered moons or captured comets. Others propose they are ancient remnants from the very birth of our solar system. Section 6. Looking back to see forward. Studying Saturn is not just about unraveling the secrets of a distant world. It's a journey that takes us deep into the heart of our own solar system, revealing the intricate dance of celestial bodies and the forces that govern them. Saturn, with its majestic rings and numerous moons, serves as a natural laboratory for scientists. By observing its atmosphere, we can learn about weather patterns and atmospheric dynamics that might also occur on other planets, including Earth. It's about understanding our own place in the cosmos. The more we learn about Saturn, the more we understand the delicate balance that allows life to thrive on our own planet. The study of Saturn's magnetic field, for instance, can provide clues about the magnetic fields of other planets, including our own. This knowledge is crucial for understanding how planets protect themselves from cosmic radiation and solar winds. By studying the formation, evolution, and composition of gas giants like Saturn, we gain valuable insights into the processes that shape planetary systems, including our own. The gas giants are like time capsules, preserving the conditions of the early solar system. They hold the keys to understanding how planets form and evolve over billions of years. Saturn's composition, with its layers of gas and liquid, offers a glimpse into the building blocks of planetary formation. Saturn's rings, for example, serve as a model for protoplanetary disks, the swirling clouds of gas and dust that surround young stars. These rings are not just beautiful to look at. They are dynamic systems that can teach us about the early stages of planet formation. By studying the interactions within these rings, scientists can infer the processes that lead to the formation of moons and planets. By studying these rings, we gain insights into the very processes that led to the formation of our own Earth and the planets around us. The particles within Saturn's rings collide and coalesce, mimicking the early stages of planetary formation. This ongoing process provides a living laboratory for scientists to observe and understand the fundamental mechanisms that have shaped our solar system. In essence, by looking back at Saturn, we are looking forward to uncovering the mysteries of our own origins and the future of planetary science. The Cassini mission, which orbited Saturn for over 13 years, provided an unprecedented look at the planet and its moons. Cassini's final plunge into Saturn's atmosphere in 2017 marked the end of an era, but also the beginning of a new one. The data collected by Cassini continues to be analyzed, offering new insights and raising new questions about Saturn and its complex system. Looking ahead, future missions to Saturn are already being planned. These missions aim to delve deeper into the mysteries of Saturn's atmosphere, its rings, and its moons. With advancements in technology, we can expect even more detailed observations and discoveries. These future missions will build on the legacy of Cassini, pushing the boundaries of our knowledge and understanding of the gas giant. One of the most exciting prospects is the exploration of Saturn's moons, particularly Enceladus and Titan. Enceladus, with its geysers spewing water vapor and organic molecules, presents a tantalizing possibility of harboring life. Titan, with its thick atmosphere and methane lakes, offers a unique environment that could provide clues about prebiotic chemistry and the conditions that might lead to life. Future missions may include landers and probes that can explore the surface and subsurface of these moons, searching for signs of life and studying their unique environments. These missions will not only enhance our understanding of Saturn and its moons, but also contribute to the broader quest of finding life beyond Earth. In conclusion, the study of Saturn is a journey of discovery that extends far beyond the planet itself. It is a quest to understand the origins and evolution of our solar system, and to explore the potential for life in the universe. By looking back at Saturn, we are not only uncovering the secrets of a distant world, but also paving the way for future explorations and discoveries that will shape our understanding of the cosmos. Section 7. Saturn, a window to the universe. Saturn, the ringed wonder, is a constant reminder of the vastness and mystery of our universe. Its swirling clouds, its hidden depths, and its enigmatic rings ignite our imaginations and inspire us to explore the unknown. Each new discovery about Saturn brings us one step closer to understanding the universe and our place within it. As we continue to explore Saturn, we unravel the secrets not just of a single planet, but of the very forces that shape the cosmos.